And then they want you to set it equal to 0 and solve it for x. So could you solve this for x for us, please?
Yeah. -7/12.
-7/12. So now it says here, and then the Pearson's always good. It tells you what it wants. It says type an ordered pair. So they want an ordered pair. The first part of the ordered pair is -7/12. The next part you get from putting this back into the original, and that's probably where most of the problems occur for students. So to do that, you really want to do it this way: -7/12 in parentheses squared plus 7 times -7/12 minus 5. What kind of calculator are you allowed to use in the course?
I think the highest you can go is a TI 84 plus.
And what do you have? Do you have one of those?
Yeah, I have a TI 84.
Okay, so you're going to want to enter it in the way I've shown you here, and then you're going to want to do this math, enter, or maybe yours would have given it to you, but you've got to be able to manipulate the numbers.
Okay.
So give this a try, please.
It says something about a syntax error. Hold on.
So that means you got to be careful to make sure that this is a negative,
Mm-hmm.
not a subtract.
Okay.
And then this one over here would be the subtract operator. And if you click on go to, it will try to tell you where it thinks there's a problem.
Okay. Oh, and then you go to math.
Yeah,
Right?
math, enter is a basically two fraction on
I got
this.
-169/24.
That is correct. So yeah, that's everything that goes in here.
Okay.
Just be super careful how you enter that. You've done all the hard work getting it right, and hate for you to, not get the credit for it because you.
Sorry. I get spam calls all the time.
That's good. It's not good. I hate that. But
Yeah. Okay. I got it in.
all right, number 3. So this one pretty straightforward. You're just taking the derivative of this. Not all questions are created equal, but
It's
what
15x
is the
squared, right?
yep.
Okay. I'm good at the power rule, but when it starts getting to the other rules, I get really confused. So,
Understood. I mean, I'll let you know if anything. I'll let you know when something more difficult comes up. All right, so here's a new problem. F prime of x, find the derivative of this. Now, there's what I call a rewrite step. I actually finally found a textbook that actually does this. Rewrite means there's no calculus. You're just doing something that you knew from a previous course. So is it, when I bring the x on the bottom up, do you remember why it's x to the -1? Is that familiar to you?
yeah, because it's a fraction.
Yes.
Yeah.
Okay, so this is much easier to take the derivative of. So could you attempt to take a derivative of this for us, please?
Yeah. Would it be 2 minus 5x to the -2?
Yes, now I believe Pearson will accept this. If you're really super concerned, you can do it this way. It should take either of them. That's one kind of advantage of doing the homeworks is you can kind of learn how it accepts the inputs, but
Yeah.
there's no guarantees, they're out there to just try to do your best you can here on this.
Mhm.
All right, so question 5, whenever you're ready, let me know.
Yeah.
Okay, so for question 5, it looks like they want you to do something really complicated. They don't.
Mhm.
You need to just take a derivative. Okay. So just take a derivative of this. Let me know what you come up with.
Okay. 4x minus 3.
You are correct. All right, let's go on to number 6. The first few go pretty fast.
Mhm.
Then they don't go so fast. So the problems, the next question here, it says to graph the derivative.
Mhm.
And well, how to do that? You first need to identify places where there's horizontal tangents. So either mins, maxes, or what are called horizontal tangents. Okay.
Okay.
And so what that does, and the way that I like showing this, if I were in a classroom, actually, so boy, that's terrible. Is you immediately graph that point. So this is the original, this is the derivative down here. Okay.
Okay.
And this is where it gets confusing. So is the graph of f, is it increasing or decreasing when it goes down and to the right?
Looks like it's decreasing to me.
Yes, yes. So down and to the right means that it's decreasing.
Okay.
Okay. And that means for its derivative, it's below 0,
Okay.
which is confusing or it's unclear. I don't know. I mean, these are just rules. If if the original function is decreasing, the derivative is below 0.
Okay.
Same thing over here on the right. Is it decreasing or increasing?
Um, to say it again.
Is this increasing or decreasing to the right here?
Decreasing.
So again, it's below 0.
Yeah.
So the challenge is, I guess, is how to get you to remember those rules, which they're kind of awkward.
Okay.
All right, so it looks like it's letter B.
Yeah.
But we get another one here. That's good. Number 7's just like it. And notice I'm doing it without looking at the answers. I know that is a good test taking strategy to do at some point, is to look at the answers. I do teach that, but sometimes you do just work out the problem.
Okay.
So again, first thing is you identify any mins or maxes. So there's a min or a max, and you immediately put that point on the x-axis
Okay.
for this. Now, on the left here, is this graph increasing or decreasing?
Um, it's coming down.
Yeah, so that's decreasing. So that means it's below.
Okay. So it
And
goes
then
down.
and then what's happening over here? Is it
It's
increasing or
increasing.
decreasing? So something like that, right? Now, if the original is a quadratic, what is the derivative?
Um, I can't remember what a quadratic looks like. It's the one that's like
Well,
a U.
I'm just asking you the power rule. The quadratic is the U shape. U shape.
Yeah.
What's the derivative of x squared?
It's gonna be oh, it's gonna be 2x.
2x, and that's the
Sorry.
equation of a line.
Sorry, I thought you were asking about the shape. I'm sorry.
Kind of. I mean, this is a quadratic roughly.
Yeah.
And so, it's x squared from path courses. So the derivative of a quadratic, which is U shape, is 2x, which is a line.
Mm-hmm.
And then you can kind of match that up with the answer down here, letter D.
Yeah.
Because you
Okay.
don't really know whether it's a line or a curve, you know. But this is the
Mhm.
only one that's reasonable.
Mhm. Gosh, maybe I didn't send you enough questions today. I might have to send you more.
Well, again, they'll go a lot slower here in a moment.
Yeah.
Let me grab the graph of this. And then we'll grab the question. So the first question wants to know where the derivative is undefined.
Mm-hmm.
So it's undefined when the slope from the left does not equal the slope from the right. So basically you're looking at any of these what are called corners. There's a corner, there's a corner, and there's a corner.
Okay.
You know, and just think about, I don't know, walking up this ramp. Like,
Mhm.
what happens when you get to this corner? Is it smooth?
No, it seems
No,
very sharp.
yeah, you fall down really badly. And then
Yeah.
same thing here, you have the problem of well, the slope from the left is this straight line down, slope from the right is this horizontal. So these corners, these are called corners. The slopes are different on each side.
Okay.
It's not smooth. I mean, imagine a roller coaster or something too, you know, you'd fly off,
Okay.
you know, or if you're building a sidewalk,
Yeah.
not good. So it's undefined and it's the X values. It's the X values you care about. So that's 0, 1, and 4.
0, 1, and 4. Okay.
And you can see the word corner in the answer. And then there's this word cusp. We'll
Mm-hmm.
talk about that in a moment here. I believe the answer is A for
Yes.
that. Now,
Yeah.
a corner is literally a corner. That's a corner.
Okay.
This is a cusp.
Okay.
So, I mean, the corners can come in a variety of forms. I mean, they're more like that. And the same with the cusp. I mean, it could look like that as well.
Okay.
Any questions on that?
No.
Okay. We grab the graph again. So at its most basic, the derivative is the slope. Okay.
Mm-hmm.
So there are 4 regions. There's region 1 there. This line right here is region 2. This is region 3, and this is region 4. You have to find the slope from region 1. Like, what is the slope from this left endpoint to this right endpoint?
Um, it would be 2/4, right?
The slope is rise over run. So how much up? Think about how much up, how
Oh,
much to the right.
it's up to over 2.
The slope of 1.
Yeah.
Okay. Now let's do the same thing for 2. We need the slope of that. So it's rise over. So this time it's going down, 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 and then over. And actually, I let you talk me into something else here. So it's up 2, but the run is 4 because it's not scaled the same on the X and Y axis
Mm-hmm.
like that.
Okay.
So sorry about that. So like on the Y axis it's scaled normally, but on the X it's not scaled the same. So how much down is it going?
7.
Okay, so down, well, down, I got 5, yeah, down 7, so that's negative, and then right 1.
Yeah.
And so the same thing for 3. Now at when it's horizontal Horizontal means that the slope is 0.
Mm-hmm.
And at 4, what's the slope at 4?
Um, uh, would it be 7/1 again?
7/1. This time it's positive because it's going
Yeah.
up and to the right. Okay, great. Now, in terms of how you graph the derivative, what you do is that in each window, so from like -4 to 0, we know the slope is -1/2. So from -4 to 0, we know that it's a slope of 1/2. So it's going to be a line like that,
Yeah.
horizontal line of that, -1/2. At in the second window, excuse me, I need my coffee. The second one is -7, so it's going to be way down here. So 1, 2, 3, it's me down here, right? Something like that, and it's open on each side. And then you have a slope of 0, so that's 0 to 0, like that. And then you got a slope of 7 there. So you're in its most simplest form, you're just graphing the slopes in each of these intervals.
Okay.
So let's look at the graphs now. Do any of these line up with what we just said roughly? I'm sorry, I don't know why I said -1/2. This one is positive. So that will line up better with this one
Yeah,
or this
B.
one. Yeah, B. All right, any questions on that before we continue?
I don't think so.
Okay. All right, figure below shows the graph of the function of the closed interval -1 to 2. So this is a cusp, not a corner.
Okay.
It kind of comes down, I don't know, more nicely. Part A, all right, so let me actually give you more explanation. So let me get rid of this black stuff there. So this thing is continuous. It's continuous because you can draw it without lifting up your pencil, but it's not differentiable at that point because at that point, the slope from the left is not the same as the slope on the right.
Okay.
But it is continuous everywhere. It's continuous because the slope from the left is the same as the slope from the right. Right. This is not the best example, but this is the one that you have in front of you here.
Okay.
So it says, at what domain point does the function appear to be differentiable? So it's everywhere except this point 0. Everywhere except 0.
Okay.
So what does that mean to you? So which of these answers says everything but 0?
It would be B.
It would be B. Good.
Yeah.
All right. So then this next one's the one we've been answering all over and over and over again. Is it says at which point does it appear to be not differentiable?
0.
0. And then the last question it asks, we've kind of already answered this, is it says, snip it in. At what point does the function appear to be neither continuous nor differentiable?
Well, it's
So,
not differentiable at all. So,
well, it's continuous everywhere.
yeah.
So this is none. It's
Okay.
sort of written oddly.
Yeah.
You would need a different graph to actually see this.
Yeah.
Okay. Was it 9? It was 9. Okay. 10 is one that we'll go relatively quickly here. Here's 10.
So, second derivative is just the derivative of the derivative. Am
That's
I
right.
right?
So, yep. So you just take one derivative, let me know what you get, and then you take another one.
Okay. For the first one, I got negative 42x to the fifth.
Okay, that's correct. And take another
42.
derivative.
I got negative 210x to the fourth.
Okay, very good. All right, so we got another question here. 11. This one will require a little bit of explanation from me,
Okay,
not a ton. But so the first two, 7x cubed over 3 minus 5x, you know how to take the derivative. Now, the derivative of e to the x is e to the x, okay?
okay,
But you have this constant in front. So there's a couple ways to look at it. One is d dx of constant times e to the x is constant times e to the x.
okay.
Or more generally, like a constant times a function, the derivative is the constant times f prime of x, like that.
Okay.
So basically, a couple ways to do it here, but why don't you give this a try and let me know what you come up with, please.
Okay. I think the only part I'm confused about is the fraction of what I would do in that case. Would it be like
So
the
just
opposite?
take the derivative of x cubed then. What's the derivative of x cubed?
Oh, x squared.
3x squared.
Oh,
All right, you
3x.
bring that.
Sorry.
So it's 7/3 times 3x squared for that part. Does that make
Okay.
sense? And then
Yes.
you deal with the fraction like you do anything else, you 7 times 3 over 3 or 3 divided by 3 times 7, however you want to do it.
Yeah. Okay.
So keep going here. Let me know what you come up with.
This is a basic algebra question, but I just forgot. When you're multiplying fractions, do you put 3x squared over 1, or do you multiply both of them by 3x squared?
Just 3 over 1, 3 over 1. That's what I was saying. You can either, like you said, multiply 7 times 3 and then divide it by 3, or you can divide first. But probably better if you just do 7 times 3 divided by 3.
Okay. Would it be 7x squared minus 5 plus 2 to the x?
That is your first derivative. Good.
Okay.
Okay, so from here, why don't you try your second derivative?
Okay. Would it be 14x plus 2 to the x?
Yes,
Okay.
that's your final answer on that. Good. So now I think I understood what you were saying. Yeah, you'll have to send over some more questions.
Okay.
You
Yeah,
can
that's
drop them
fine.
in the chat, or you can send another email, whatever is best for you.
How do I drop it in the chat?
So you just take a screenshot and the way you've been doing, and you just paste it into the chat here. I'll just send you a message. You can do one at a time, or you should be able to just right click and paste or control V, your keyboard person.
Capture. I think that worked. Did I sent you through 12, right? Or no?
Let me look. I thought it was,
If
11,
I
but
didn't, sorry. I thought I did.
I only see. Well, maybe.
I'll send you
Oh,
12 anyway.
yeah.
How many
All right,
more?
there's.
Like 3?
Yeah, so there you go. So I got, so that's in the chat. So, it's up to you if you want to snip the full screen. I would recommend just snipping the part, that we need, because it'll add a bunch of this extra stuff.
Okay.
In fact, yeah, probably better not to have that in there. I can sort of process it here by doing a snip and then a snip, but it's up to you.
I think I cut this one. We'll see. It's letting me screenshot on the chat and send it over. I'm trying to like
Yeah,
cross.
just because I
Sorry.
do like to upload these to YouTube, I'd like to not have some of those words in there referred for everyone.
Yeah.
Last thing is Rio Salado sending me a cease and desist letter. To the point in my life. So let me know when you're ready. We can work through number 12 here.
Yeah, I'm ready.
Okay, so the first thing is kind of this rewrite step. You want to write this as 8x to the -7, which already is -5x to the -1, like that. And why don't you try taking a derivative of this, please?
Okay. I got -56x to the -8 plus 5x to the -2.
Good. And so you want to continue that for the next part here.
Yes. I got 448x to the -9th minus 10x to the -3.
Yeah, really good.
Like I said, the power rule doesn't freak me out. It's so easy, but I do not like the other stuff.
Yeah, so that's what we got here. Number 13 is a new derivative rule.
Yay.
All right, so let me know when you're ready.
Yeah, give me 1 sec. I'm just typing it in the quiz. Okay. Okay. Yeah, I'm ready.
Okay, so for number 13, it's a new derivative rule. This one is called the quotient rule. And depending on where you've seen this before, a lot of teachers use F and G. I like U and V. Do you have a preference for what you've
It
seen
doesn't
before?
matter. I'll
All right,
understand what you mean.
all right. So F is 4x minus 7, and G is 3x plus 1. So could you give me F prime and G prime, please?
Yes. It's just 4 for F
4
prime.
and yeah, and G prime.
G prime is just 3.
Good. So now Y is really F over G.
Okay.
Okay, and then when you take a derivative of them both, okay, then this is what's called the quotient rule. So you're going to hear me say this in words, not formulas, but it's the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared.
Okay. Jeez.
All right, and so now it's just a matter of putting in those things back into the equation here. So it's 3x plus 1 times 4 minus 4x minus 7 times 3 over 3x plus 1 squared. And I
Okay,
believe it will take this way, like you don't need to simplify it. And you should use parentheses to kind of like group terms to kind of organize it.
mm-hmm. So I can put it in that way,
Yes, yes.
okay.
Generally we'll accept that.
Sorry, my X was in caps. I had to go through and change it.
Yeah, that's another thing it'll complain about.
Yeah. Okay, got it.
All right, so whenever you're ready, if you want to send over another question, we can look at
Okay,
it.
oh my gosh, I'm not sending enough. I'm sorry.
That's okay. It's okay to do it one at a time. We'll get through as much as we can.
Okay, how do I crop it?
Well, so I use the snipping. I have a Windows computer, so I use the snipping tool. I know you're just probably doing a print screen, but the snipping tool will allow you to just, and it's literally just called the snipping tool. You just crop what you want, or you just snip what you want, and then you can just paste that in the chat.
I got it. I have a
Okay.
Mac, so it's Command
Yeah.
Shift 4, I think. Yeah,
Okay.
I'll send 2 more. I think that's good. Or should I send 3?
Oh, it doesn't matter. I'm just gonna do them in the order they come in. We'll talk you through them.
I'll
So,
do these 2 because there's a square root in one of these. I'm not
so
good
this
at
one is a more difficult, like this is product rule with what's called chain rule.
Mhm.
Which, well, actually I take that back. We're gonna do this differently. This is not, so this is 14.
Yes, it is.
Okay. Actually, it's just not written well. So if we do a rewrite, it's really 5t minus 1 over 3t minus 6, like that. Sorry,
Okay.
it is just a quotient rule problem here again. So again, you make this f and g. I always write them out kind of off to the side here, like this. So you want to be consistent with how you do it. What is f prime and what is g prime in that scenario?
F prime is 5 and G prime is 3.
Right. So now your derivative rule is, the derivative is bottom times derivative of the top minus top times derivative of the bottom over the bottom square. Now it's just a matter of plug and chug. Just put these numbers in, write them out. So it's bottom 3t minus 6 times 5 minus 5t minus 1 times 3 all over the bottom squared. Just take your time entering that. It's very important that you get all that in there.
Yeah. Okay, I got it.
All right, so the next problem here, if you dropped in the chat, keep in mind the quizzes are not a good representation of the order. You would see that's in there, just sort of there, out kind of out there
Yeah.
floating. But So this is one of those where it looks like it's quotient rule because you got a
Mhm.
top and a bottom, but you would actually divide each of these by x
Okay,
like this. And then you would further rewrite it by like simplifying. Now, remember that square root of x is x to the 1/2. So this is 9x to the -1. Is that clear why the
yes,
bottom comes up? Okay. And there's no calculus, so we've not taken any derivatives. Plus 4
okay,
minus 8x to the 1/2 over x to the 1. This becomes x to the 1/2 minus 1, which is x to the -1/2. So 9x to the -1 plus 4 minus x to the -1/2, like that.
okay,
Now we're ready to take a derivative. Okay, like you really do want to do this. It is better than the quotient rule.
okay. Would it be -9x to the -2 plus 1/2 over x to the 1.5?
I would probably go this way with it. I would just leave the exponents negative. Like when you subtract 1, it becomes -3/2.
Okay, okay, okay.
Whenever you're ready, if you want to send over another question, we can.
Yeah,
I get at least one more done for today.
yeah, I think this one, I think I understand it, but I just want to make sure I'm right, considering that they're multiplied together. What is it doing? It was letting me do this before. There.
All right, so we're finally up to product rule. This usually comes before quotient rule. So
Okay,
the idea here is that this is really an f times a g, and you just have to figure out that breakpoint right there. So the f here is f to the 10, g is e to the x, and you have to be able to take a derivative of each of these individually. So could you do that for us, please?
yes. F prime would be 10x to the 9th. G
Okay.
prime would be e to the x.
Good. So the quotient, I'm sorry, the product rule derivative,
Okay.
and it's gonna sound really similar to what we've been doing. It's the first times the derivative of the second plus the second times the derivative of the first. Now you can kind of rearrange it a little bit if you prefer a different language, or maybe you saw it differently, F prime G plus G prime F. Doesn't really matter. You're basically pairing up these things diagonally. If you're going to pair up an F with a G prime,
Okay.
and then you're going to pair up an F prime with a G like that. And the order doesn't really matter. So because it's multiplication addition. So it's x to the 10 e to the x
Mm-hmm.
plus 10x to the 9th e to the x like that.
Okay.
So that's what I meant by pairing them up diagonally. They pair up like that.
And that's how you enter the problem?
Yep. Yep. I mean, there's a few other ways you could do it, but this is good enough. This will work.
Okay.
All right. Okay. If we stop here for today.
Yeah, of course.
All right. So we're going to stop the recording.